Good afternoon, y'all. Welcome to the teaching seminar for our candidate for the aquatic weed science position, Eli Russell. A very brief bio to this group, since most of you may or not know the seminar. So Eli is currently a doctoral student at Virginia Tech, currently expected to graduate in August this year. Finish his program there. He is from Alabama and did his undergraduate and master's work at Auburn University, so War Eagle. And some interesting things, he's really focused on a really unique piece of research in his doctoral work on seed mills and their role in dealing with weed seed production coming through combines. And it's sort of a unique area of weed science that's really exploding right now. And so you got to hear that. We've recorded that research seminar. If you're interested in that, I'll be making that link available later. Our goal today, I asked for a teaching seminar. Now, not for a full 50-minute lecture, because I know your attention spans are a little bit lower than that these days. Just kidding. But I asked for a 20-minute lecture. And the purpose in that was to sort of give an introduction to a topic associated with aquatic weed science, okay? And so following that, there will be a time for Q&A. You'll feel free to ask questions about the lecture itself. We will then end the recording and the faculty will depart. And this will be specifically a time for Eli to be with the agronomy graduate students, okay? Now, I will say that he will be spending some time at CAIP tomorrow with the CAPE graduate students, but in general, you're welcome to have a discussion about anything. And so that will not be recorded, and this will be your time with the candidate, okay? Any questions about that? Okay, Eli, I'd like to turn it over to you for the seminar.
All right, well, thank you, Dr. Hamler, for that introduction. Yeah, so we're gonna have a teaching seminar today, but before I get started, I'm gonna kind of walk through some of my teaching experience and my philosophy. So there we go. All right, so throughout my time as a grad student, I've had the opportunity to be the GTA for 6 courses. Some notable ones there are Principles of Weed Science. I've been the TA for Pest Management 2 times, and then Weeds That Shape Our World, which is a very interesting class. And over that time, I've been able to give 8 lectures and guest lectures. I've taught 3 labs in their entirety for those classes. But I think the most important experience I have as a teaching, as a GTA has been from pest management. So this class is divided into 3 sections where students in one semester learn how to control diseases, insects, and weeds all in one go. And so they just truly divide this class into thirds for each topic. And we have faculty members for pathology and entomology to teach these their portion, but they don't really have a weed scientist that teaches it. So they usually ask a grad student to step in. And this has been a great experience because I have to fill in lectures, provide guest lectures, and basically teach the entire third of a class. It's like a mini session on how to run a class, because the other professors they would be there if I needed help, but they're just kind of like, well, this is yours. I'll see you at the final. So, you have to write tests and, do discussions with the students to see what they're learning, what needs to be covered. And you can see it's a pretty big class. It's the class this past year on the left. We have a lot of students, so it's really fun to be able to work with quite a diverse and big class as well. Now, outside of actual teaching experience, one thing that has been really beneficial, I believe, in being able to teach students has been the Virginia Tech Weed Team. So there are 2 weed contests every year, hosted, one by the Southern Weed Science Society and Northeast Weed Science Society, where Virginia Tech brings a team and we compete. And as a leading member of the team, I've had plenty of opportunities to instruct graduate students and undergrads on a lot of the topics within that. So teaching weed ID of over 200 species to these students, learning how to calibrate a sprayer and any math related to that, teaching them those methods, diagnosing farmer problems, so teaching them how to walk up to a problem and work with a farmer for an unknown issue that they have in the field and how to solve it, and then identifying unknown herbicides. So when you walk into a field and you see symptoms, what herbicide has been sprayed. So I've had an opportunity to teach all of these sections. I'm actually currently in the throes of being the one in charge of sprayer calibration, because our professor who usually works with that told me 2 weeks ago that for the next 3 weeks, I'm gonna be in Switzerland, so that's on you. So I get a lot of experience working with especially graduate students, which are different in my mind than teaching undergrad. So it's a lot of hands-on experience in a less formal setting, but it's still teaching nonetheless. And I think it's been very important for my growth in that area. Now, my teaching philosophy centers around one big point, and that is passion. As an undergrad student, the 2 classes that I loved the most as an undergrad was taught by professors who were very passionate about what they did. You knew that without a shadow of a doubt that is what they were meant to do in this life. And I think when you have a very passionate professor, it really rubs off on the students. So I really love weed science. I'm very passionate about it. And so I would like to bring that passion into the classroom. I also want to use interactive labs and hands-on learning in the classroom setting. I know some students learn better by being able to actually fill a weed or actually calibrate a sprayer. These are things, if I can bring it into the classroom so that they can see it in person, actually have experience with it, I would like to do that. And then also targeted lectures. So I want to know what these students want to do in life so that we can try to gear some of that lecture material to really fit what they want to do. For instance, in the pest management course, historically, this has been a row crop based course because most of the students want to do that. But in past years, we've had a really strong percentage, 30 to 40% of these students come from a turf background, and they want to go on later and work on golf courses. So learning about how to control weeds in a cotton field or a cornfield doesn't really apply to them, and they don't really care to learn that. So finding out that these students want to go work on golf courses later, we started gearing the lectures to really incorporate a lot of turf weed science components because it really helps relate to the changing student demographics of this class. Now, when it comes to just measuring progress, I'm pretty standard on that. I like exams. I know some people get real stressed out about exams, but I think they're a great way to really assess where your students are at. But on a more day-to-day level, I think in-class and online discussions really help you assess students' progress throughout the course, especially like a week-to-week basis. And then finally, I would like to implement in my classes a writing assignment, because I think that writing assignments are really good for testing critical thinking as well as communication skills. And when students take the step from after graduation into the real world, these are things that really help in their careers. So outside of the classes that are in this appointment, I think that there's an opportunity to teach a weed science graduate student course. I have met a lot of grad students going into weed science that did not have a good undergraduate course there. I know Virginia Tech doesn't offer an undergraduate weed science course. And so we have graduate students starting in weed science who really do not have a foundational knowledge to build their degree upon. And I think that they're really missing out on the potential of their degree because they just don't have things. Like general information as far as being able to identify weeds, herbicide chemistry, and things of that nature. Now, I think that back to the weed team, this could double as a weed team or weed contest preparation course. The weed contest really allows students to get in front of employers. I got my first offer from grad school from the weed contest. A lot of people get offers for additional, whether they want to go to a master's or a PhD from the weed contest, they meet their future employers. There's a lot of industry support at these weed contests. So I think, not only could this class be great for just grad students who need to learn about weed science, but also if you choose to participate in the weed contest, it can really help you professionally as well. And then I think that there's an opportunity to develop a UF Quest course. I know that this is something that can be really difficult. But it's really a long-term goal that I would really like to shoot for, because if we can start getting more people outside of the department into some of these courses where they can learn about aquatic habitats and what we do, I think we can really increase our impact. So with that, it's kind of the basics, got to get, talk about some of these things for the faculty that are listening, but we'll start with the lecture. So the the topic Dr. Enlow gave me was linking submerged aquatic plant biology in integrated weed management. Now, I don't have my presenter view and the actual little weed control booklet I stole these illustrations from. But I do want to point them out. I love to collect old weed science books because they're just very interesting. So I had this one, I think it was like How to Control Aquatic and Algae Aquatic Environments. It's a really old book. It's just full of illustrations. I really like these pictures. So I figured I'd point that out. Now, when it comes to controlling aquatic weeds, this is something that is very unique in terms of just general weed control, because now we're dealing with an environment that has a lot of water in it. It's not like we can just get in our tractor, drive over and spray. And so even if we're dealing with emergent plants, which grow out of the bank, stems and the leaves grow above the water, if we're dealing with floating plants that just float on the water, or if we're dealing with submerged plants under the water surface, all of these plant groups really have their own unique challenges when it comes to managing. But of this group, there's one that is really different, even when you throw in some of your shoreline plants and your upland plants, and that is this submerged group. And because it's under the water, it really changes how you go about managing it. For instance, if I were to take an airplane and fly it over this environment and spray all of these weeds, there would be some that die. So if I spray, let's just say Roundup, it works pretty good. We're going to kill our upland plants. We're going to kill our shoreline. Our emergent, we're going to get good contact, even though it's in the water. Still got plenty of plant material above the water that we're going to get contact. Fingers crossed, we should get some good kill rates. Floating plants, again, these plants are still above the water. We're going to get good contact with a herbicide if we were to spray it. But our submerged plants, we're not going to be able to hit that with an aerial application. And that is one thing that really makes controlling aquatic plants difficult, because we're no longer controlling at a 2D level. We've got a lot of factors to include, such as the volume of the water that we're in. And so as soon as that herbicide hits that water, it's just going to slowly dilute, and you're probably not even going to get enough contact with the plant to even think about control. So submerged aquatic weeds really make life difficult because of this growth habit that they have. And so again, as I said, we're no longer treating an area like you would with terrestrial plants or the other aquatic plants that we deal with. We're treating this volume. And so I have my next slide. So when it comes to controlling these submerged plants, the best thing we need to do is use an integrated weed management system. So if you don't know, an integrated weed management system is a system that layers multiple weed control methods to suppress and manage weed. So these weeds might be difficult to control, but the good thing is we have a lot of methods to use. For instance, on the baseline of every weed management system is prevention. If we don't have a weed, we don't have to control a weed. Just remember that. So keeping a weed out is really the bottom line for all of your weed management issues. But most people who deal with weeds are already beyond this point. So what about our other options for controlling these submerged aquatic weeds? Well, we could use mechanical weed control. We can cut, transport, remove these weeds with the use of harvesters. That has great potential, even the ones that are under the water. We could use biological. A historic case is the alligator weed flea beetle. That was a great biological control agent for alligator weed. But could we could use a living organism to control these submerged aquatic plants. We could use physical or cultural methods that manipulate the environment. So for instance, with these submerged weeds, if we add a dye in the water, we can limit the amount of light that for photosynthesis, because again, we can put a physical barrier in between them and the light. Now, if we have floating plants, we couldn't do that, because even with a dye in the water, they can still get plenty of light. But for submerged weeds, there are options. And then finally, everybody's favorite, at least row crops, the chemical option. Herbicides are a great way to kill plants, makes life easy. So I know what some of you are thinking, why are we even worried about the rest of these? Herbicides are great, always. That's what people tend to say in row crops. So why not just spray those? Why do we even need to worry about an integrated weed management system? And well, partly with herbicide resistance, you always got to worry. You always have to use other weed control strategies. But even outside of chemical, everything has a drawback when we're talking about dealing with submerged aquatic vegetation. So if we walk through these for mechanical, harvesters are great. We can remove a lot of weeds, but one issue is it's time consuming. It takes a lot of time to effectively use this one single harvester. We also can't remove the whole plant. When we're talking about submerged vegetation, we have a lot of issues with this. One, if you're working with something like hydrilla and it can fragment, and those fragments can start new growth somewhere else in the river or the lake, this can be an issue. As opposed to like floating plants, which are a lot easier to see, a lot easier to bring that whole plant into the harvester, especially like water hyacinth, because it's just floating on the top of the water. But with our submerged plants, we might not be able to get all the way to the bottom of that plant when we are harvesting it. And if you have any perennial plants, you're going to leave things like tubers in the soil. And so we're not going to be able to get all of the plant all the time with these harvesters. In addition to that, these are not always very effective in shallow water. So since these submerged plants are typically rooted, they're going to sometimes start in some of that shallower water and then expand out into the lake. Now we can get what's in the deeper water quite effectively, but all those plants that we're leaving along the shoreline where it's too shallow to get a harvester, all those plants are just waiting for the opportunity to rebound and double in size and just expand back out to where they were when you harvested it the first time. So what about biological? Biological seems like a good idea. We had the alligator weed flea beetle. It worked great. That's still in use today. Well, for a lot of our submerged weeds, we don't have a ton of options, at least our problematic ones. But one big issue is you kind of need some high densities of these biological control agents. If you don't have a high density, you're not going to get, the weed will be able to overcome any of the feeding that these insects or other animals do on the plant. From the very beginning, it takes a long time to find an acceptable agent. And when you do, they're not always selective for a single species. Carp, for instance, are going to feed on multiple different species of submerged vegetation, even if they're native. So if you have native plants out there that you want to keep and you want to get rid of non-native weeds, you're gonna lose some of those natives with carp. Now you might be able to still reduce your native population or your invasive populations, but sometimes there's others that'll suffer. Now, what about physical or cultural? There are some great weed control strategies within this method. For instance, lake drawdown. We draw down and remove that water, we can expose those weeds to the sun and really get good control. Again, as we talked about, we can use dyes to kind of stop the light from penetrating into the water to get to those plants for photosynthesis. But there are some issues with these control methods, even though they have some good, you can use these in different areas for widespread control. Some things are, again, they are non-selective. If you put a dye in the water, all the submerged plants will be affected. If you draw down the lake, any of those weeds will be affected, whether you wanted them or not. Two, these methods are not always successful. For instance, if you use a dye, weeds like hydrilla can still photosynthesize even in poor light conditions. So while you might slow its growth, you're probably still not going to kill it. And then finally, these are really not applicable in all systems. Not every lake is set up to be able to draw down water and then add water back, as well as some lakes are just way too big to add dye. Or they have a too high of an exchange rate of the water. You would be adding dye constantly to make sure that it's to the right concentration to actually impede the growth of those plants. Now, what about chemical? We've got lots of options when it comes to controlling aquatic weeds with herbicides. There are a lot of registered herbicides within Florida, but not all of these can be used for submerged aquatic plants. As we talked about with the illustration at the very beginning, getting herbicide to those plants can be a challenge. And so some of these herbicides like glyphosate, imazapyr and sethoxydim don't have activity in the water. So if you put them in the water, they're just not going to be able to kill these submerged weeds. Now, the good thing is we still have a lot of options that are available to us, but there's still challenges when it comes to controlling submerged weeds with herbicides. One thing, as we mentioned, we're treating a volume. And so because it's not just putting herbicide on a leaf and letting it absorb into a plant, it's a little more complicated than that. It takes, for some of our herbicides, a really long exposure time with that herbicide to actually get control. In the case of herbicides like fluoridone, in some reports I've seen up to 90 days of exposure time to that herbicide to actually get effective control. And so 90 days is a long time. You can just about grow short season corn in that amount of time. So, you know, that's a really long time to keep concentration in a water body. So you're also, again, treating a volume, not an area. And this is its own issue when it comes to calibration, because it's not just saying, oh, I got to spray 3 acres. I'm spraying 3 pints the acre, 9 pints. Let's go do it. You got to really take the average depth of this lake, and you got to really, you got to take in exchange rates. There's just a lot of factors that you really have to consider when trying to control these submerged weeds. Again, often with this long exposure time, you have to maintain high enough concentrations for killing these plants. It's not just about having some herbicide in the water. It's about having a killing dose in the water for a long enough amount of time. And then because of this, and how some of these herbicides will leave this water column as flow rate changes in a lake, or with certain flow rates in the lake, and certain herbicides break down. Fluoridone, it might need 90 days, but it breaks down a lot faster than 90 days. So you're going to need multiple applications of some of these herbicides to ensure that you are actually killing these submerged plants. Now, we've talked about all the issues of using these individually, but what about if we take these and we use them together? So we have drawbacks of all of these, but this is part of building an integrated weed management system, is using multiple methods so that we can target this weed for full control and basically pick up where some of these have weaknesses. So for example, if we have hydrilla in a lake, can we use a harvester to harvest what's in the deeper water? And then once we've kind of cleared up some of that deeper water hydrilla, can we release a biological control agent such as carp to feed on that hydrilla in the shallower area? So we can get a more effective control by combining these two, because the carp will be able to feed on what's in the shallow area, but they can't always handle all of the biomass that's available in that water column. So if we can use a harvester to remove some of that bulk biomass from the middle, release carp, we could get more effective control. Or what if we did a lake drawdown and we reduce the volume of the lake so that it's easier to come in after and apply herbicide and get the effective concentrations that we need to kill those weeds. So this is just 2 very brief examples of how we can actually take multiple control methods, pair them together to kind of overcome some of the weaknesses that we might deal with a single control method alone. So I believe I've kept it to the point. Oh, one other thing, if you don't know, there's a great aquatic weed management resource through the Center of Aquatic and Invasive Plants. I learned a lot on this site, so I wanted to just point y'all to this. If you don't know and you're curious, it goes way more in depth, and I just kind of scratched the surface of some of this. So with that, I'll leave you with one of my favorite sites near where I live currently. This is the New River. And it's a very, very beautiful river. We've got mountains in the background. But one thing I noticed when I was looking at this picture the other day, actually, is if you look very closely, no matter how beautiful it is, we're always going to have some of these submerged weeds down here in the corner. So weeds are everywhere you go. You just got to keep an eye out for them. So with that, I'll take any questions.
All right, questions for Eli in the lecture or teaching philosophy, anything like that.
My kind of group.
So you were mentioning targeting your lectures to like the student
Mhm.
groups and other interested in. Would you be interested in targeting lectures of more about the aquatic angle?
Yes, so so one of the classes that this position would teach is aquatic plant management.
Okay.
And so the goal of that one is hopefully we'll just be covering aquatic weeds the whole time, I guess. But you know, depending on whether or not people want to go to grad school or go to industry, after they graduate, these are things that we can kind of bring in different people who have experience in some of those areas and try to give them an idea of what careers after, you know, how aquatic plant management affects their job, so that they can see what it can mean for them once they graduate.
So, because aquatic weed management includes the general public, how would you approach stakeholders that are concerned about the use of chemicals? Because we face that a lot in this, a lot more than in agriculture.
Yes, that is true. Talking to stakeholders that have concerns about chemicals can be challenging because sometimes they don't, no matter what the science says, sometimes they just don't believe it. And part of that is they just don't understand it fully. And so I think it's our job as scientists to provide them with information, really kind of start trying to connect the points where they're missing information. And so sometimes that's as simple as saying, you know, this is what the herbicide label says. You know, it says that it's safe to swim in this immediately after application, 1 day after application. But also sometimes they don't trust that. You know, there's a lot of, I guess, mistrust around big companies. So, you know, trying to point to the fact that a lot of these chemicals have to go through rigorous testing with the EPA, you know, and sometimes it's really hard to get really in depth with that. But I think if you really have a concerned stakeholder, these are things you really need to talk with them about it. Being able to work through, you know, asking them questions to figure out where their mistrust, you know, starts, and then trying to slowly work through that to one, build a relationship, but also show that this is the science behind why we have all this. I guess.
What would you say are some of the differences in approaching weed management from a more private agricultural angle versus the aquatic to the more ecological?
Yes, so it really depends on your stakeholder and really at the foundation of it, what your use is. Some people, if you like to fish a lot, you really might want some of those aquatic weeds that most people want to get rid of out in your pond or your lake, whatever. So when it comes to approaching like a private individual in terms of control, you really got to figure out what their angle is like. What are they using this water about? As far as more general control, that's what makes aquatic weed management difficult, is because you're trying to satisfy a lot of different stakeholder opinions in a public water body for control. Some people want to keep it, some people want to kill it, some people want to keep native species, some people don't want to see any plants. So, you know, even from a general use perspective, and this also again starts tying into kind of this ecological viewpoint of we need to keep some of these native species truly, but some people might not want any plants. Some people just might like seeing a lot of plants, whether they're native or invasive, and say that's a lot of biodiversity. So this kind of goes back to one, knowing what the stakeholder wants, but also educating them on how, yes, you might have some hydrilla or some hyacinth out there and it might look great, but probably don't need it.
Yeah, I was wondering, just from like a teaching perspective,
Uh-huh.
you already have any specific ideas of the kinds of, the actual hands-on experience you would want a student to be engaging with?
Yes, so one, I really want students to be able to like experience weeds. One, in person, but also try to get them to an area where we can actually look at them in their environment. You know, weeds look very different in a greenhouse versus seeing them out in a lake or in a river. So I really enjoy weed walks. It's not the way I like to, it's what we do a lot. Lab I'm in. And so just walking around and looking at weeds, how they, what they're doing with their environment as they are. So I think that would be one example. It really kind of depends on the size of the class. You know, when we start talking about different kinds of equipment for controlling weeds, can we get them in front of a harvester? Can we show them how to calibrate a spray boat? And actually getting experience with those pieces of equipment would be something I really like.
So thank you for the lecture. So we know that, for example, we ran 6 on like depending on the aquatic systems or depending on the, I can say where the weeds are, for example, the crops can be hit with the zero planes. In turf grass, it can affect maybe the acid quality of the turf. But in the aquatic weeds management, what is the main problems of the weeds in the water?
Yeah, so a lot of this, again, comes down to stakeholder abuse. If you want native plants, it could be some of the problems with potted plants is they're competing with native plants. You don't want that. Very similar to how, like you said, weeds can compete with our turf grass. You don't want those there. But also when it comes to things like being able to use the water for various things, commercially, as far as shipping, or power generation, like a river to generate power, hydro plant. All of these things can be affected by aquatic weeds. If you have too many aquatic weeds in the lake, you can't get a boat through it. You know, and so that also carries over to public uses, especially in a lake. If you have too many weeds in a lake, you really can't run a boat through it. But again, some people that, for instance, fishermen like to see some aquatic plants out there. So trying to strike that balance between how many weeds you want out there and how many you don't can be quite difficult in this space. It's not quite like row crops or turf where the answer is none. So I only want the one species I want.
You mentioned you were interested in teaching a UF Quest course.
Yes.
I've never heard of that before. What is it?
Yeah, so it's kind of like this course that really spans the university. So it's not like a department only course. And it kind of creates like a shared experience between all of the, I guess, students. So if you're in some kind of like social science major, there are these handful of courses that you have to take that everybody in the university has to take. I know at Auburn, we had 9 course types we had to take. So we had to take like 1 geography, 1 social science, but this would be a way to get kind of one of these courses into like one of the general science categories and really expand our impact outside of people who would never have experience with aquatic environments.
Any online questions?
Anybody raise your hand online or put it in the chat box either way?
There you go.
Oh, excellent question.
Yeah, so online question is, will applying chemical and water cause concerns for drinking water? Then in the soil. So this is always a concern. This, I guess, points back to your question on, stakeholder concerns with applying chemicals. When it comes to applying chemicals in water, especially water that people use, the EPA is very rigorous in what they will allow. And if there's even a hint of concern when it comes to applying chemicals in water, whether that's affecting insects, people, dogs, animals, birds, they won't let it through. So if you look at the label, a lot of these herbicides, they have, they're very, very safe terms of their toxicity with little to none at all. And again, even if we're not putting toxic chemicals as far as to humans and animals into the water, but when we are adding these chemicals to the water, they're at such a low rate. You already have a diluted product, but when you're putting it into the water, some of these herbicides are going out in like parts per billion, very, very low parts per million into the water. So we're talking a microscopic amount in compared to all the water that's. Because 1 part per million is 1 milligram for every liter of water. So it's a very, very small amount.
All right, any other questions from the audience, from the Zoom audience?
We have one more in-house if we don't have anyone.
I was just curious, what are you getting your PhD in specifically? What are you studying?
Yes, my PhD is in applied crop weed science. Yeah, so I work a lot with corn and wheat and pasture grasses. But I work mostly with weeds.
Okay, thank you, Elon.
Yeah.
So this will conclude the teaching seminar aspect. We will shut down the recording now.